We're going to start our notes on 10.2, and 10.2 is on counterexamples. If you were to go to your book and actually look and read, there are a whole lot of ideas that are being taught in 10.2, but we're not going to focus on a lot of them. What I'm going to do is narrow it down, and we're only going to focus on one idea, and the one idea that I want you to focus on is called counterexamples. The name of 10.2 is called Patterns in Inductive Reasoning. So some of the things that you're going to look at today, you're going to think, how is this math? And it's math because we're talking about your reasoning skills. The type of skill when you start thinking to yourself, is this true? Is it always true? Is it sometimes true? And things like that. Okay? So let's start off with the word, or this statement. In math, for something to be true, then it always has to be true. In math, for something to be true, then it always has to be true. When you make a statement in math, that statement needs to always be true. For example, 2 plus 2 is always, 2 plus 2 is always 4. In order for that to be true, it has to always be true. It can't be sometimes true, sometimes 2, sometimes plus 2 is 4. No, it's always 4. Okay? So what we're going to be doing is we're going to be trying to prove things false. We're going to be trying to prove things false by using a counterexample. Our goal is to prove things are false by providing one counterexample. How many? 1. Our goal is to prove things are false by providing one counterexample. And the last thing I think I need to define before we do an example is what is a counterexample. So let's define what that word means. Counterexample. What it means. It's an instance in which the pattern or conjecture does not work. A counterexample is an instant in which the pattern or conjecture does not work. I'm going to give you an example. And this example is like number 4 on your worksheet. Number 4 on your worksheet says this. If a quadrilateral has 4 sides, then it is a square. This is the weirdest kind of math that we do almost all year right here, because it's reasoning. If a quadrilateral has 4 sides, then it is a square. Okay? So there's going to be a statement. This statement has a hypothesis and a conclusion. It has, if a quadrilateral has 4 sides, then it is a square. Now, what I started you with was this statement. In math, for something to be true, then it always has to be true. And what we're going to be doing is we're going to be proving things are false by providing one example that shows that this is not true. Okay? If a quadrilateral has 4 sides and it is square, this is not always true. This is false. We have to provide a counterexample for this statement. If a quadrilateral has 4 sides, then it is a square. What could it be if it has 4 sides? Give me an example where it couldn't, where it has 4 sides and it's not a square.
A rectangle.
Rectangle. Is that the only counterexample you can come up with?
Rhombus.
A rhombus. It could be a rhombus. What else could it be?
Kite.
A kite. Parallelogram. A trapezoid. It could be any of those shapes. Do I have to provide all 5 of those? No. All we have to do is prove things are false by providing one counterexample. Okay? So all I have to do say is false. A trapezoid, whatever you want to use. You could say rectangle. You could say a trapezoid is a quadrilateral with 4 sides, and it is not a square. The last one that I'm going to do with you is number 7. And this one's very difficult, which is why we're going to do it together. This is what number 7 says. AB is equal to BC. Known. AB is equal to BC. Conjecture. I didn't define conjecture because you don't really need to know it, but I'll tell you what conjecture means. A conjecture is like a hypothesis in science. It's an idea. This is what I think is true. That's what a conjecture is. It's an idea that you think is true or that somebody else thinks is true. B is the midpoint of AC. So in this particular case, we know that AB and BC are the same length. That is known. That's not part of the guess. We cannot refute this first statement. This first statement is true. The conjecture is that B has to be the midpoint of AC. So in your mind, you might be thinking of a few things. AB is the same as BC. Does B have to be the midpoint of AC? Let's think about that, okay? A, B, C. If you were to draw this where AB is the same length as BC, B might look like it's in the middle or is the midpoint. Can you think, well, let's just draw it like that. Let's just put right here, right here, right here. And this is the same length as this. Is B going to be the midpoint the way that this is drawn?
Yeah.
Okay. Now what we need to do is we need to think of an instance where the B is not the midpoint, but those two lengths are still the same.
If you put them on a plane?
Put them on a plane. I don't know if that would separate it. What do you think? An equilateral triangle. I like that. Or we can make a triangle from it. What were you going to say?
An unknown plane that's not on
Is there an unknown point that's not on
there?
there?
Or like if there was, then it wouldn't be there.
Still might be if it's the same length. Because B is the same in both of these. Isn't B the same as both? So let's go with Tim's idea. Tim said, let's try a triangle. What if you were to change this and maybe put the A, the B, and the C in different spots? Like that. His counterexample is a drawing, and that is perfectly fine if you want to do a drawing or a statement in words. But let's think about this. Is AB, let's say this length is however many inches it is, 1 inch or 10 inches, I don't know. And BC is 1 inch or 10 inches. Is B the exact middle of AC?
Yeah.
Is it the midpoint?
No.
No. So don't forget, our definition of what a midpoint is it has to be exactly in the middle between these 2 points. Right here is probably where the midpoint of AC would be. Does that make sense to you? Like the reason B is not the midpoint is because the midpoint of AC is right here. It has to be on segment AC. That's my counterexample. This is an excellent counterexample. It shows a picture where it's not true. Okay? We're going to stop your notes right there.